Hi students, today we are going to see how can we add two vectors. In the last section I told you vectors cannot be added in the normal way. They have to be added using vector algebra. So we are going to see how to add two vectors. Okay. I am just taking two vectors. This is vector A and this is vector B. Here you can see two vectors are in the same direction. If two vectors are in the same direction, you can add those two vectors just the magnitude. For example, if this magnitude is 5, this magnitude is 3, you can get the answer as 5 plus 3 is equal to 8. So when I add the vector, I will be getting a bigger line because I am adding both the two lines, right? So I will be getting a bigger vector and the sum of the vectors is called resultant. Sum of the two vectors is called resultant. I just write vector R. Vector R is equal to vector A plus vector B. Okay. So vector R is equal to vector A plus vector B. That is just a representation. How am I getting that? How will I calculate the value? Value is calculated like this. The modulus of vector R. Modulus meaning value or magnitude. Modulus of vector R can be calculated as the modulus of vector A plus modulus of vector B. That means 5 plus 3, 8. That's the concept. Now, so this is the first case. Now going towards the second case, I am just taking a vector. This is vector A. This is vector A and this is vector B. So two vectors, vector A plus vector B. So you can see both these vectors are in the opposite direction, right? They are of different magnitude but in the opposite direction. So what I have to do is bigger magnitude minus smaller magnitude, and the direction will be the direction of the bigger vector. Say for example, this is 5, this is 3, then you have to do 5 minus 3, which is 2, and direction will be the direction of the bigger vector. So I will draw the answer like this. This length subtracted this length will give you a smaller length, but it is in the direction of vector B itself. So I will write like this: vector R is equal to vector A plus vector B. Actually what we did, we subtracted, but what we wrote, vector A plus vector B, because we are studying vector addition. In vector addition, if two vectors are in opposite direction, the addition is done by subtracting bigger magnitude from smaller magnitude. Okay, so representation will not change. Representation will always comes like this only: vector A plus vector B is equal to vector R. So I can write like this. We are finding the magnitude. Vector R is equal to modulus of vector B minus modulus of vector A. We subtracted bigger from the smaller and you got the magnitude, and the representation is like vector R is equal to vector A plus vector B. This is what we are doing when two vectors are acting in the opposite directions. Now comes the most important thing. What will happen if two vectors are in different direction? Say for example, a car is moving towards east, another car is moving towards north. Then how will I take the resultant? Can I add both of them? Obviously not. So how will I do vector addition if two vectors are in different directions. Okay, let us see. So two cases are there. You can write these two cases, and then we are moving on to third case. Triangular law of vector addition. Triangular law of vector addition. This is the third case. When two vectors are in different direction, we use triangular law of vector addition. So what is triangular law? Look at the figure very carefully. This is vector A. 1 minute. This is vector A. I have just shown the vector like this, and this is vector B, and the angle between two vectors is theta. Because they are in different directions, the angle between them is theta. We can't add them properly. So what I have to do is, I am going to use triangular law. What you have to do is, suppose imagine my pen is vector B. Okay, I keep the pen like this. Without changing the angle, just shift this pen towards the head of A and keep it like this. I'll show once more. This is my pen which is in the direction of B. Without shifting the angle, just slide the pen like this and keep the tail of the pen on the head of A. So you will get a vector in this direction. That is what I have drawn here. Okay, that is what I have drawn here. I have shifted vector B without changing its angle and keep the tail of B on the tail of A. So this is actually my vector B, and this is actually my vector A. So you have two vectors now, vector A, vector B, and I put a dotted line and then mark the angle theta. So these two are two sides of a triangle. Then you draw the third side along the opposite direction. That will give you the resultant vector. So I put an arrow here just to show that it is the resultant in this direction. Okay. So one vector is like this, second vector is like this. Then you draw the triangle. Draw the third side of the triangle taken in the opposite order, which will give you the resultant. What is meant by opposite order? I'll tell you. It is simple. See, first vector I draw it like this. First vector I draw it like this. Second vector is drawing like this. Third vector you will prefer to draw in this way. That is the same direction. But I am not drawing like that. I am drawing like this, opposite way. That is why it is told the third side is taken in the opposite order, which will give the resultant. Okay. So I'm just writing like that. Now, angle between two vectors, angle between vector A and vector B is theta, and the angle between the first vector and the resultant vector is alpha. So what is alpha? Alpha is the angle between the first vector and the resultant vector. Theta is the angle between two vectors. So I just wrote here vector A plus vector B. That is only a representation. Now, how will you find the magnitude? The magnitude of the vector is found by modulus of vector R equal to root of A square plus B square plus 2AB cos theta. Using this equation only, you will be able to find the magnitude. And the direction of the vector can be found by this. Tan alpha is equal to B sin theta by A plus B cos theta. B sin theta by A plus B cos theta. Using that, you can find the angle alpha, and that angle will be the direction. Okay. So this is one method. If two vectors are in different direction, this is one method. So you can please draw the diagrams, equations, and the statements. Okay. Now there is one more method to do this. See, this is parallelogram law of vector addition. Here what I did is, Here what I did is, this is vector A, this is vector B. Instead of taking this vector and putting it over here, I am just putting the tail of this vector on the tail of A. Tail to tail. In the previous one, I took this tail to the head of A. But in this case, I take the tail of this vector and keep at the tail of A itself. So I got this as vector A, this as vector B. Both are two sides of the parallelogram. Now I put the dotted line and I completed the parallelogram, and the diagonal of the parallelogram gives the resultant. So that yellow line is actually my diagonal, that is the resultant. So I will write here vector R is equal to vector A plus vector B. Again I am saying that is just a representation. That is just a representation. Vector R is equal to vector A plus vector B. That is just a representation. What actually I am doing? Modulus is found by root of A square plus B square plus 2AB cos theta, and direction is given by tan alpha is equal to B sin theta by A plus B cos theta. So this is what I am really doing. When you look the triangular law and parallelogram law, you can see equations are exactly same. And just see the previous figure. This yellow line is the resultant. Look at this figure. This yellow line is the resultant. Both of them are in the same direction, which means whether I am taking triangular law or parallelogram law, I will always get the answer in the same direction. Same values, same direction, everything same. So triangular law and parallelogram law, both are the different considerations to do vector addition when two vectors are in different direction. Okay, so copy the figures and copy the statement also. That's all for now. Thank you.